geometry. Sorry, I was just wondering what it'd be like to be a great white shark. Uh, let's get started on a section. It's chapter six, or sorry, it's chapter eight, but it's lesson six. And I have to say, this is going to be a little more difficult section. It's called the law of sines. Put on your thinking caps, get ready to go, and let's attack it. All right, let's take a triangle, any old triangle, and we'll give it corners A, B, and C, and we'll give the sides opposite those corners small a, this would be small c, this would be small b. And if we cut, we not cut this, but draw an altitude here to make this part a right triangle. So to be clear, we're making this part a right triangle. We'll call this H. Let's think about how to find the area of a triangle, okay? So the area of a triangle, is going to be 1/2 base times height. Furthermore, we know that, let's look at angle A here. We know that the sine for angle A, and just look at the red part here, it's going to be the opposite over the hypotenuse, right? So it's going to be H over C. Oops, not capital C, lowercase c. Okay, are you with me? Do a little manipulation with algebra. Multiply c over there because we want to get h by itself. So h is going to equal c times sine a. Right? Let's do a little substitution. We have h here and we have h there. So we're going to substitute this in for h. I'm trying to make sure this gets on camera. So we're going to have 1/2. Sorry, this is area equals 1/2 base times c sine a. So, look at this whole entire triangle. So here's angle A. If we want to find the area of this triangle, find sine of A and, sine of A, multiply it by the two sides, the two legs on either side of that angle, so B and C, and then take half of that. By the same exact reasoning, we could do sine of C multiplied by the two legs on the opposite side, A and B, and take half of that. We could take sine of B and multiply it by the two legs on the opposite sides, A and C, and take half of that. So that's your first key concept. It's the area of a triangle, and I'll try to make this a little less messy here. The area of any triangle is 1/2 BC sine A, or it's 1/2 AB sine C, or 1/2 AC sine B. They have that for you on page 616, okay? So that's your first handy little formula. You can use this to find any area of a triangle. All you need to know is an angle and the lengths of two sides on either side of that angle. Okay, now let's hit the actual law of sines. Okay, so for the law of sines, we're going to start with this. We're going to start by putting all those area formulas that we just figured out equal to each other. And then let's get rid of the 1/2 part. So multiply everybody by 2, okay? So you get BC times sine A equals AC times sine B equals AB sine C. And now let's divide every one of them by ABC. So do you see B is going to cancel B, C is going to cancel C. A is going to cancel A, C is going to cancel C, A, B, and B. So you end up with the sine of A over A equals the sine of B over B equals the sine of C over C. There you have the law of sines, and that's on page 617. Now, the way you're going to use this mostly is by what's called solving a triangle. So let me erase this part so I can show you up above. And let's just do an example that they give. They give an example in example 2. Okay? So they show a triangle. Looks something like that. It's got 80, 45, and then it's got B3, not C, 3, and A here. So let's work on figuring out what we need to know here. So we first need to know this angle, right? Well, you know if it's 80 plus 45, that's 125, and 180 is going to be the total of all three angles. So 180 minus 125, last time I checked, is 55. So now let's use this. We want to find out, we want something involving this 3 because that's a known. So 3 is going to be the side opposite of C. This was C to begin with. Sorry, capital C. This was A to begin with, and this was B to begin with. So we know the sine of C over 3 is the sine of B over B, right? Okay, so C is 80 degrees, right? And B is 45 degrees. And so now I think we have enough info to solve this. So, sine of 80 degrees. Oops. Sorry, guess I don't know how to use it. I use this calculator. Sine 80 degrees equals 0.98 and the sine of 45 degrees, 0.71 basically rounded. And if we want to solve for B, we're going to take 0.98 divided by 3, and then we're going to multiply b times that. And then we're going to divide this by the 0.33, right? So 0.71 divided by 0.33 gives you about 2.15. So we know that the length of B, the length of B is 2.15. Let's do the length of A now. And then we'll have everything. Okay, so we want this one. So we want this, the sine of A, so the sine of 55 degrees over A equals, and we can use any of these we want. Let's just do this one since we already know what it is. The sine of 80 degrees over 3. And the sine of 80 degrees, I already forgot what it was. Sine 80 equals 0.98. Sine of 55 degrees, 0.82. Let's do this in a little more organized manner now. Can you see this? Let's cross multiply, okay? So 0.98 A equals 3 times 0.82. So 0.82 times 3 equals, and then we're going to divide that by a 0.98, 2.5. So this is going to be about 2.5, 2.51. Okay, so there. We've solved a triangle, and I think you should be able to use the same method for a lot of things. And, okay, there's one more thing we have to talk about. And this is on page 618. So let me erase this and let's go through it. Okay, so you can use the law of sines anytime that you know two angles and a side, okay? So angle, angle, side, you're good. Angle, side, angle, you're good. You can also use it if you have side, side angle. But it's a little more what they call ambiguous. It doesn't always mean that there's only one triangle or even a triangle. You can have two sides at an angle and you can know both those things and it can still not make a triangle. And on page 618, they kind of take you through a bunch of possibilities. So let's talk about this just for a bit. Let's say we had a triangle, and this is angle A, this is going to be B, and they're going to call this side that you don't quite know, well, you know about it, you know how long it is, it's A. We don't know this bottom one. So if A here is less than the height, can you see it's not even going to attach? There's going to be 0 triangles in that case. So if A is not long enough to reach all the way down there, depending on what that angle is, and depending on that length, it's going to make 0 triangles. If A just perfectly comes down, is just the right length to touch, then you're going to have only one triangle. But what if A was longer than that? Longer than that, and I don't know if I can show you this. Oh yeah. imagine it was like this more, okay? Well, then it could touch there, or it could touch there. There's two possible triangles it could make there. So in that case, if A was longer, you could have a triangle there, you could have a triangle there. There would be two possibilities. That's if this angle is acute. If this angle was obtuse, something like this, we'll call this A again, call this B, and call this small a. Well, you could still have this be too short to reach down there. That would be 0 triangles. This time, though, you're not going to have the case where if this is too long, well, I don't even have too long of a pen, but if this was too long, you don't have the case where it's going to be able to swing in. So if that was long, you could have one triangle, and that's it. So they give you the 6 different possibilities. It's on page 618, and I understand that's a lot, but I think they should visually make sense to you. Look at them, because there might be more than one that you have to solve for sometimes when you solve a triangle. Okay, are you tired? I'm exhausted just doing this. So anyway, sit back. You know, it's like after a good meal. Sit back and just let it rumble through your, unbutton your pants. Let it just rumble in there out like after Thanksgiving. And hopefully it'll make sense to you as you do some practice. And we are going to have some practice tomorrow. Okay, see you guys.